Hi guys, today we're going to talk about section 2.3, which is how to clear out fractions and decimals off a linear equation. So if you have the sheet or notes from class, or you can download it from the Blackboard from the week 1 folder, you're going to see that there are a couple of things that we need to figure out. One is that to figure out how to clear out fractions, and the other one is to figure out how to clear out decimals. In class, we ran out of time, so we did a couple questions very briefly about how to clear out fractions. And one thing I want to make sure that we change is that on the sheet, on number 2, it says clear out fractions in a linear equation, and on the sheet it says GCF is your BFF, and the correction here is it's not GCF, it's LCD. Okay, so make sure we, oops, that's not what I want to do. Make sure we use LCD is your BFF. Okay, lowest common denominator is your BFF. So essentially, let's talk about how to clear out fractions to remind ourselves. To clear out fractions in a linear equation, you will multiply both sides of the equation using lowest common denominator. So for example, the first problem we're going to be dealing with is 1/4 x minus 2 over 7 equal 1 over 2x plus 2. Okay. Now, I did provide a YouTube video link on how to find the lowest common denominator. Now, I did not make that video, but that is the method that I would prefer you to use. So take a look if you haven't had a chance to take a look yet. All right. So here we go. In this case, we're looking at the denominators. So I have a denominator of 4, denominator of 7, denominator of 2, and the denominator of 1. Okay, again, math people are lazy, so I need to assume that the denominator here is 1. But the 1 is not going to affect us too much. So in this case, we need to figure out, is there a number that I can multiply that will cancel out 4, 7, and the 2 at the same time? Okay, so the number that we're going to use here is 28. Because 4 goes into 28, 7 goes into 28, and 2 also goes into 28. Okay? So we're going to multiply both sides by 28. And then we're going to distribute the 28 into the parentheses that I just wrote. And this is where, in class, I keep saying, when you multiply fractions, it is better if you you cancel first, you reduce first, before you multiply. So here we go. So 28 divided by 4 is 7. So I have 7 times x is 7x. Minus 28 divided by 7 is 4. So 4 times 2 is 8. And 28 times 1/2, right? Or 28 divided by 2 is 14. So I have 14x. Plus, and 2 times 28, notice, right? 2 now is on the top, now on the bottom. So 2 times 28 is 56. Okay, and we just turned this into a problem where there are no more fractions and just strictly integers. And this one will be really easy to handle. So essentially, this problem now becomes the problem we did in 2.2, where we're going to move all the variables to one side and any terms that does not have variable to the other side. Okay, so I'm going to minus 14x on both sides. And so I have negative 7x minus 8 equal 56. I'm going to add 8 to both sides. So to isolate the x, or in an attempt to isolate the x, so I have negative 7x equal 64. And to finish out the problem, divide both sides by negative 7. So x equal 64 over negative 7, and I'm totally okay with that. Okay. So that's how you clear it out fractions. All right, let's do the next question. 2b. This time our equation is 1 over 3q plus 3/5 equal 1 over 15q minus 2 over 5. And in this case, the lowest common denominator, right? Again, we need a number that 3, 5, 15 all go into. So in this case, 15 works. Because 3 goes into 15, 5 goes into 15, and 15 obviously goes into 15. So we're going to multiply both sides by 15. I'm sorry, I run out of space. My space management on this problem is not very good. So, all right, and again, we distribute 15 divided by 3. So 15 times 1/3 means 15 divided by 3, which is 5q. Plus 15 times 3/5 means 15 divided by 5, which is 3. Then times 3, which gives you 9. Equal 15 divided by 15 is 1. So I just have 1q. And minus 15 times 2/5. So means 15 divided by 5 is 3. And 3 times 2 is 6. Okay. All right, to finish the problem, I'm going to move all the q's on the left-hand side. So I'm going to minus 1q on both sides. So I have 4q plus 9 equal negative 6. And then I'm going to minus 9 on both sides. So I have 4q equal negative 15. So q equal negative 15 divided by 4. Okay. All right, and I believe these are the two problems that we did in class because we ran out of time. So again, right, the biggest thing is find the common denominator and then multiply the denominator on both sides, the common denominator on both sides, to cancel out all the denominators so you no longer has to deal with fractions. All right, last problem for the number 2. What we end up having here is we have 5y minus 1 over 2 minus y plus 4 over 5 equal to 1. This one, only denominators you're dealing with are 2 and 5. So I know that LCD is 10. Right? 2 times 5 is 10. So I'm going to multiply both sides by 10. Okay. Now this one is slightly awkward because your numerator for the fractions, it has multiple terms in it, right? 5y minus 1 is 2 terms. And y plus 4 in the second fraction, that's also 2 terms. So we just got to be careful once we distribute our lowest common denominator. Make sure everything gets multiplied. And you'll see how I write it. So same idea, 10 divided by 2, right? If I distribute 10 into the first fraction, the denominator is 2. So 10 divided by 2 is 5. So I have 5 times 5y minus 1. Okay, notice I put the parentheses around 5y minus 1. Minus, same thing. When the 10 distribute into the second fraction, right? 10 divided by 5 is 2. So I have 2 parentheses y plus 4. Equal, the right-hand side is pretty straightforward. 1 times 10 is 10. Nothing tricky about that. Okay, now on the left-hand side, we need to finish distributing. So 5 times 5y is 25y, minus 5 times 1 is 5. Okay, and here, depending on how you learned, right, most people, they take the negative 2 and distribute. So you get a minus 2y and minus 8. So it just depends on how you learn to distribute. I don't care how you do it as long as you can do it right consistently. Equal to 10. Okay, left hand side of the equation, I have 25y minus 5 minus 2y minus 8. I need to combine like terms. So which means I'm going to bring everything to the right hand side because I'm going to run out of space. 25y minus 2y is 23y. Minus 5 minus 8 is minus 13. Equal to 10. Okay, this one's a little easier. I'm going to add 13 to both sides. So I get 23y equals 23. So divide by 23 on both sides, y equal to 1. So this one's a pretty nice answer. Okay, not too bad. Okay, so again, to clear out fractions in a linear equation, please think about using common denominator. Okay, common denominator is going to be your BFF, and you'll cancel out all the fractions, so you don't have to deal with fractions anymore. All right, let's go ahead and move on to the next page. The next topic is clear out decimals in a linear equation. Okay, so let's just look at the first example. 6.3x minus 1.5 equal 4.8. Okay, now the thing you need to know is that multiplying by 10 or powers of 10 moves decimals. Okay, so in this case, let's think about it. See, notice all these terms we have are 1 decimal place. I can't spell today. Decimal place. So if I want to move everything 1 decimal place, right, I have to multiply by 10. And reason being that is if I multiply everything by 10, instead of 6.3, I am going to get 63x. Instead of 1.5, if I do 1.5 times 10, I get 15. Instead of 4.8, if I do 4.8 by 10, I get 48. Okay, I know it doesn't really make that much of a difference, but for a lot of students, not seeing decimals actually make things feel easier. So this is the reason why we move the decimal points by multiplying both sides by 10 or powers of 10. So we're only dealing with integers. So now to finish this problem, I'm just gonna plus 15 on both sides. 63x equal 63. So divide by 63 on both sides. X equal to 1. Okay, right? And the answer is not going to change because when we multiply both sides by 10, right, we're using the property of equality. Right, that means that the answer does not change, even though we kind of changed how the problem looks. Okay, second problem. 0.05z plus 0.2 equals 0.15z minus 10.5. Okay, so again, right, your goal is try to get rid of clear out the decimals. So in this case, I am going to look for the term that has the most decimal places, and then that's going to tell me what number to multiply on both sides. So in this case, notice these two terms has 2 decimal places compared to the other problem, compared to the other terms. Right, the other only has 1 place. Which means if I want to clear out the decimal out of everything, I gotta move it 2 places, which means I need to multiply by 100. Okay, so basically every place you had to move, you gotta multiply by 10. So if I want to if I want to move 2 places, I got to multiply by 10, right, twice. That's why 10 times 10 is 100. So we're going to multiply everything by 100. So multiply both sides by 100. And we're going to distribute. So, right, so 100 times 0.05 is just 5. All we're doing is we're moving the decimal places 2 places to the right. So 5z plus 100 times 0.2 is 20. Again, we just move the decimal point 2 places to the right. Equal 100 times 0.15z is 15z minus 100 times 10.5 is 1050. Again, we're just moving decimal places 2 places to the right. All right. So then this problem becomes easier, right? It's just whole numbers. So I'm going to minus 15z on both sides. I get negative 10z plus 20 equal negative 1050. Then I'm going to minus 20 on both sides, so I can get all the terms that does not have variables on the other side. So negative 10z equal negative 1070. And then divide by negative 10. So z equal negative divided by negative is positive. 1070 divided by 10, which is 107. So z is 107. Okay. All right, third problem we have here is 3c. You got 0.06 times g minus 0.5 equals 0.06g plus 0.01. So what you could actually do here is, first thing first, if you can distribute first if you want, or you can just go ahead and multiply everything by 100. And the reason I say you can multiply both sides by 100 is that you have the 0.06, 0.06, and the 0.01. Those are 2 decimal places. Okay, so actually I think what I'm going to do. I'm going to multiply by both sides by 100, just make life a little easier. So here we go. Okay, so here I multiply both sides by 100. So now let's figure out what's going on here. 100 times 0.06 is 6. So I have 6 parentheses g minus 0.5 equal 100 times 0.06g is 6g plus 100 times 0.01 is 1. Okay, so on the left-hand side, I'm going to have to do a little bit of a distribution, just because I think that's the things that we got to do. So I have 6g minus, now 6 times 0.05 is 3, equals 6g plus 1. And hey, check this out. You have 6g's on both sides. So that means if I minus 6g on both sides, I get negative 3 equal 1. And this right here tells me this is a false statement. So no solution. Okay. So this problem is a doozy, right? We ended up with no solution, but the process of getting to no solution is by multiplying both sides by 100, right, to clear out the decimal points, just because the decimal point makes things a little bit messy. But so our goal is that try to make the least amount of mess that we had to deal with, the possible, right? The least amount of mess we had to deal with, the best. All right, So again, right? So your job for these to clear out the decimals is to try to figure out how many decimal places that you have to move. You have to clear it out, and in turns multiply by 10, by 100, by 1,000, right? Depending on how many places you have. Okay, number 4 is the curveball. Right, curveball, like I said before, curveball means usually there's a little bit confusing, a little bit harder. So, well, let's give it a shot. 0.78 minus 1 over 25h equal 3 over 5h minus 0.5. And so looking at this problem, looks like we have a mixture of decimal point and fractions. And the one good thing about this is that if you look at it, look at the fraction. The denominator for the fraction are 25 or 5, and those are pretty nice numbers to work with. Okay, so I am going to multiply both sides by 100. Reason being, right, I'm dealing decimal-wise. I'm dealing with 0.7a and a 0.5. 0.7a is 2 decimal places, so to clear that out, I need to multiply by 100. So I'm going to multiply both sides by 100. Okay, and then I'm going to go ahead and distribute. So 100 times 0.78 is 78. Minus. Now, what is 100 times 1 over 25? Well, 100 divided by 25 is 4. So this is 4h. Equals. Distribute 100 again. Alright, so 100 times 3/5. Now, that means 100 divided by 5, and then multiply by 3. So 100 divided by 5 is 20, and 20 times 3 is 60. So I have 60h. Minus, now 0.5 times 100, that's basically half of 100, so that's 50. So I think this one's not too bad. Okay, so this problem is actually okay, right? I mean, you multiply by 100, you'll cancel out all the fractions, and you cleared out all the decimals. So not a bad idea. Okay, so let's go ahead and finish this problem. I'm going to move all the h to the left-hand side as a habit. So minus 60h on both sides. And that will give me 70h because we haven't moved it yet. Minus 64h equal negative 50. And then now I got an h on the left-hand side, so the 78's got to be moved. So I'm going to minus 78 on both sides. I get negative 64h equal minus 50 minus 78, that's minus 128. I think the answer is going to turn out fairly decent for this one. To get h by itself, I had to divide both sides by negative 64. So h in this case is just go ahead and be 2. Right, negative divided by negative is positive. 128 divided by 64 is 2. So h equal to 2. Okay, hopefully this video will help you get through section 2.3. Again, lowest common factor is going to be your BFF when you're dealing fractions, and when you're trying to clear out decimals, right? You just gotta look at how many decimal places you have to clear, and you'll be multiplied by 10, 100, or 1,000, or 10,000, depending on how many decimal places that you had to clear. Any questions? Please let me know. I'll talk to you later.